So today I have brought with me the heavyweight chapter of your PU2 Maths syllabus, Continuity and Differentiability. The best part about this chapter is not only that it carries 17 marks, but also it is easier when you compare to the other counterpart of this similar marks, which is integrals. Also comes for 18 marks, but this is much easier when you compare that to integrals. So this becomes one of the highest priority in our preparation. Okay, so today I'm here to discuss your blueprint in detail, what type of question they can ask us, and later we'll move on to our theory discussion. We'll also learn some concept, the important concepts, and we'll solve question on each of the categories. So if you're ready to start the session, give me a thumbs up right now, and do not forget to hit the subscribe button if you're watching me for the first time. Okay, so let's start from our blueprint. What is the weightage of this particular chapter, which is very important? Have a look. Check this out. We have 1 marker, short answer 2 marker, short answer 3 marker, long answer 4 marker and 5 marker from here, which becomes exactly 7 questions, and the weightage becomes 17 marks from this particular chapter. 3 MCQs comes. We have one of the question from 2 marker, one from 3 marker, and so on till 5 mark. Okay, so very important. I hope you can see the weightage. This is as per the latest blueprint given by your boards. And if you move on to the session plan, what I'm gonna give to you today will be starting from the most important topics discussion. I'll discuss the topics with concepts. Then I'll move on to the questions. We have today 25 questions to discuss. So we have total 8 MCQs, 2 marker questions is again 4, and 3 marker is 8, and we have 5 marker, again 5 more questions. And later we'll get to know, again this is just a list of topics and I'll discuss them over here as well. Okay, so this is clear. So let's start discussion with the understanding each of this important concept. The first one is continuity. Yes, this question will come for 4 marks. So I'll tell you what concept can be asked in which category. So this will come for 4 marks. On this concept, questions comes on 4 marks. What is the concept? How do we define a given function continuous? Or if the given function is continuous and you find the missing variable, are you able to recall those questions? Yes. So when can we say given function is continuous? Okay, so fx, a given function, is said to be continuous if what? If the limit of the function fx at the point x tends to a should be equal to f of a. If the limit function of the function at the point a is equal to the function value at a, then you call the given function to be continuous. Okay, now in the limit, of course, to define the limit you need to there's a different criteria. Only you have to find the LHL and you have to find the RHL that you have learnt in your PU1 syllabus. Okay, so you know how to find the limit for the certain functions. Whenever I've taught you, I have given for in detail discussion of finding the limit, but in the syllabus, in this particular question, we'll use most of the time your LH rule, because this is faster and errorless. So we use LH rule. What is LH rule? L Hospital's rule we're going to use to find the limit condition, and we'll put it equal to f of a. If they are a missing variable, we'll find that value. If not, we'll prove that the given function is continuous. Okay, now for differentiability, we have the first principle. To prove for differentiability, right? To prove for differentiability, we have the one method is from the first principle. But in your questions, you don't use it that often. What you actually use is you define the function. The method 2 is actually redefine the function. Okay, basically like this. So let's say the critical point is x more than equal to a or x less than a. You define the function in both the places. Okay, and what you're gonna do? Differentiate it for that. You're gonna differentiate it for these both areas. Okay, so for x more than a and for x less than a, let's write the function as something called as here as px and qx. Okay, then you're gonna get the value as p dash of x and q dash of x. P dash of x and q dash of x. If it is equal in both of them, if it is equal to means if p dash of a is equals to q dash of a, then we call the given function to be differentiable. Okay, differentiable. If if, listen to me very carefully, you're going to redefine the function in this format, x more than a, x less than a. We have the two different formats given to you, and we're going to differentiate both of them individually and find the value using the derivatives at the point a. If they are equal, then we call it as the LHD, the left hand derivative is equals to what? The right hand derivative. When that is true, we call the given function to be differentiable, and this is the method that we're going to use to solve most of our questions. That's why I stick to this particular method, and this is continuity basic understanding of when to prove the given function continuous. I hope this is very much clear to all of you. Next, algebra of continuous function. On this, over a period of time, if you say for the last 10 years, 4 to 5 times they have asked questions on this, and I have also taken questions on this, where you have to prove that the given function f and g are continuous. The function f and g is looking like q actually, one second. The function f and g are continuous either in an interval or a point, okay, at a point, let's say a, at a point a, then even f plus g is continuous, okay, or f minus g is continuous, okay, is also continuous. Third one, f into g is also continuous, okay, and we have the last one, f by g is also continuous, provided that g is non-zero at the point a. G is non-zero at the point a. Is it clear? If g of a is non-zero, means f of g is also continuous. This is your basic algebra of continuity. Okay, next. What next concept? Derivative formula for various function. Even though it looks very silly, but yes, the MCQ side, no, focus on this particular concept. For all the functions, whether it is trigonometric, logarithmic, exponential function, or a general polynomial function, for all of these, direct questions comes, and if you don't know the quotient rule, the product rule, you end up making mistakes in it. Okay, so derivative formula for various function is very, very important. Let's try from the very first one that we have, the polynomial function y equal to, if we have a power x power n, derivative is given as what? A n x power n minus 1. And of course you can keep continuing like this. Y equal to, if I have e power x, derivative is also equals to e power x. If you have y equal to a power x, derivative is what? Derivative is a power x ln a. A power x ln a. And for the fourth one, check here. If I have y equal to ln x, derivative is y dash given as 1 by x. If you have fifth one, y equal to log of x with the base a. If the base is not natural value, then it becomes derivative as 1 by x ln a. 1 by x ln a. Okay. Now this is the basics for the polynomial and exponential logarithmic function. Now we're going to move on to the trigonometric ones. Check here. If I have y equal to sin x, derivative is y equal to cos x. Seventh one, y equal to cos x, if I have, derivative is going to be minus sin x actually. And if I have y equal to tan x, derivative is what? Sec square x. If I have y equal to cot x, derivative is minus cosec square x. 10th one, y equal to, if I have sec x, derivative is y dash equals to sec x tan x. And 11th one, if I have y equal to cosec x, derivative is what? Minus cosec x and cot x. Okay, these are the 6, I think, yeah, 6 trigonometric function. We also have for inverse trigonometric function, y equal to, if I have sine inverse of x, then derivative is what? 1 upon root of 1 minus x square. If I have, very important, if I have cos inverse, it will become simply minus sine, but this is the most important. If I have tan inverse of x, it will become y dash as 1 upon 1 plus x square. 1 upon 1 plus x square. I hope this is clear. 1 upon 1 plus x square. Okay. So as I was saying, for this one, for y equal to cos inverse of x, the y dash becomes what? Excuse me. The y dash becomes equals to 1 upon, sorry, minus 1 upon root of 1 minus x square, and we have for sec inverse, cosec inverse and cot inverse as well. For cot inverse is going to be minus 1 upon 1 plus x square. For cosec inverse and sec inverse is going to be 1 upon x times of 1 minus x square and so on. Okay, if you want, they're not that used in board syllabus, but if you want I can write it for you. For I'll write for y equal to sec inverse, let's say. So I'll have y dash as 1 upon x times of and so on. Okay, but not that useful. I'm going to remove it, okay, for other three. Less used, very, very less used. Okay, so these are the main important points when you say the formulas are concerned. Have a look, 1 second, from here also. Yes, so now it's time to learn some rules of derivatives. Some rules, very, very important. The very basics, I hope you all know that, but it's okay. We are here to revise them as well. The first one is the product rule. The first one is the product rule. What is that? For product rule, if I have two functions, let's say f into g, I'm looking for their derivative. Answer is very simple. Differentiate first one, keeping this one as it is, plus keep the first one as it is, differentiate the second one. Now in the case of product rule, there is no order over here. You can go ahead with the g first and keeping f as it is, f as it is, derivative of g into f. You can keep anyway because this is going to be plus sign, okay? But when you go to the other rules, you'll see next is what? The quotient rule. Next is the quotient rule. Now in this the order matters. For example, if I have a function given in this format, f by g, I'm looking for the derivative. I have to do for derivative of f first, keeping g as it is, minus sign will come. This time you're going to keep f as it is, differentiate g, divide by the function in the denominator square. Okay, the function in the denominator square. And the last and the most important one is the chain rule. Okay, the chain rule, because what happens over here, no, let's say if I'm trying to differentiate a function which is in terms of another variable or another function, for example, log of sine t, and this is a function given as y, and I'm looking for dy by dx. I'm looking for the value of dy by dx. Then check, I have how many functions to differentiate. First, when I do dy by dx, no, we'll differentiate first log. So I'll have 1 upon sine t. Okay, 1 upon sine t. Now differentiate, this is the first function, log differentiated. Next I want to differentiate sine. So I'll get cos t. Is it over? No. I'll differentiate t also because we have to get in terms of x. So we have to write here dt by dx. Now what is the answer actually? The answer is cos by sine. So cot t dt by dx. Cot t dt by dx. This is your answer for the chain rule. It's very important. You have to learn to apply it very in the correct fashion, otherwise you'll lose a lot of marks over here. Do not miss out on because usually we remember about product rule and quotient rule, but in the questions we forget about the last derivative of the function t. If it was x, it'll become dx by x, which is 1. If this value was not t, it was actually x. If this was just x, this will become what? X. The answer will be for this as 1 if it is dx by dx. Okay, but in this case it is dt by dx, so we have to keep it as dt by dx. I hope this is clear for all of you. Next we have parametric form and second derivative. Again, highly important and question based approach that we are learning over here. We have one more reason, which is logarithmic differentiation. That also comes for 3 marks. I'll tell you that when I'm solving a question on it. Okay, I'll explain you that concept over there. Over here we'll learn 2 methods, which is parametric form and derivatives, second order derivative. So whenever you have a function given, let's say y, in terms of a function t, okay, and I have a function, what, let's call it as x, also in terms of another function, I'll write g this time, g of t. So both the functions are defined in terms of a parameter, which is t and t. And what are they asking? Differentiate them like this, dy by dx they're asking. Then what are you going to do? Differentiate f by dt and g by dt and take their ratios. Looks simple? It is simple. We'll solve them when the question comes, don't worry. Okay, next let's learn what is it? Second derivative. Now for the second derivative, what is there? Simply second derivative is nothing but as the name suggests, derivative of the first derivative. So we have a symbol for it, t square y upon dx square. We can also write sometimes as y2 or y double dash, your choice. Okay, but we usually write it as d square y upon dx square. This is given by derivative with x of what? The first derivative. This is your first derivative. This is your first derivative. Am I right? Yes. This is my first derivative. So this is nothing but derivative of first derivative is called as second derivative. Okay. Now it's time for questions, sir. It's time for questions starting from MCQs. Are you ready? Let's start from the question number 1. Again from the question bank, which is question number 41 from parametric form. This is from 41 of parametric form. Let's solve it. What do we get? We need to find the value of dy by dx. We'll go like this, dy by dt upon dx by dt. Have a look. For this we have 2a. If you differentiate 2at, you'll get 2a, and if you differentiate this one, you'll get what? 2at, because a is a constant. Derivative of t square is going to be 2t. So 2at, this is cancelled. Answer is 1 by t. Answer is 1 by t, which is the option number C. Option number C. I hope this is clear. Clear enough? Okay. Next, so we are doing what? Now we learned and revised our important topics. We're going to move on to solve the questions on them. Okay. Next is what? Derivative of 2 root cot x square. This is based upon chain rule. This is based upon chain rule. Very, very important question. Check here. Y is given as 2 root of cot x square. How many functions we have over here? We have first function as the root, second is cot, then is x square. Okay. Shall y1 we are finding derivative form 2 as it is. Derivative of this root will be what? 1 upon 2 root of the same thing. I hope you know this. Derivative of root x is what? 1 upon 2 root x. Same thing. Okay. Check here. If I have a function y equals to root x, derivative of this is given by 1 upon 2 root x. From which approach? Polynomial derivative. Okay. Chali. Let's move on to this now. So we have over here derivative of first function is done, the root function. Then we're going to differentiate cot. We'll get here minus cosec, same variable. Okay, the angle which is the same, cosec x square. Next, derivative of x square, which is nothing but 2x. Check here, this 2 and this 2 is cancelled. Now option you check, minus, because of this minus sign, minus 2x cosec x square by root cot x square. Answer is option C. Answer is option C. Clear? Simple. Next. Here you go. We have derivative of this function. Again, a concept of chain rule. So differentiate sine of x square plus 5 will become cos of x square plus 5 as it is. And derivative of x square plus 5 will be what? 2x. What is my answer? 2x cos of x square plus 5. Okay, so your answer is, who is the answer? This one, option D. Option D is the right answer. Okay, done. Yes, questions like this can also come in examination. They're very, very simple. Okay, not everything will be difficult for you. And anyway, this chapter is easier when compared to the other high weighted chapter, which is integrals, 18 marks. Okay. Again, this question is on what? This question is on the algebra of continuity. If f and g are two real functions continuous at x equals to c, then which one is true? Check here. Discontinuous, no. Discontinuous, no. No, this is the right answer. F by g is continuous provided g of c is non-zero. So I gave you 4 options now for addition, subtraction, multiplication, and the ratio, the quotient. This becomes here the right statement. Other 3 are wrong. Option D is the correct choice. So see, if you know the concept, you can directly get the answer over here. The derivative of f given by fx equals sine inverse of x exists, means this function here is differentiable in what domain? In what domain? That's what they're asking us. Differentiable in what domain? Check here, sine inverse of x. The domain is minus 1 to 1. Minus 1 to 1. Option B is right. So you need to know what? For some questions you need to know your principal value branches as well. Okay, from ITF. Clear? Okay. Next, y equal to log of log x with the base 7. find the derivative. So y dash, for differentiate this function, so we'll get 1 by log first, 1 by log x, and for this we'll get what? ln 7, okay, and we'll have the answer for this log as 1 by x. So 1 by x log x ln 7. So this is the answer, option A, right? Option A. I gave you the formulas for these for that point only, because if you know the formulas you can get the answers directly. As I said, these formulas that you see over here are very much important, are very important to solve direct questions in the MCQ, especially MCQs, and there are 3 MCQs in the blueprint that is going to come from this particular chapter. Okay, let's continue. So we were, I think, here. Okay, this also is done. Next, the function given fx as x plus 1 x minus 1 is what? Modulus function is always continuous. Yes, we have a critical point over here, mod of x plus 1 plus mod of x minus 1. Okay, this function will have critical point at x equals to minus 1 and x equals to plus 1. And the graph of this function, if you remember, looks like this. Okay, this is minus 1, this is plus 1. So if you take over here, okay, plus and plus, this will be what? X plus x. Okay, this will be plus here, and this will be minus. So yeah, so basically 2, this is the value 2, and if you take the positive of both, it will become 2x. So this is your function, this is your graph actually. This graph is 2x over here, this value is 2, this is minus 2x. How can I say that? Expand it in 3 cases. Expand in 3 cases. Check here, case 1. When what? When x is less than minus 1. Okay, less than minus 1, both will be negative. So you'll get this function as minus x minus 1 and minus x minus 1. Sorry, minus x plus 1. Check this out. You'll get this function as minus x minus 1. Over here you'll get minus x plus 1. So 1 and 1 cancels. You have only minus 2x left. Okay, and you can go with the case 2 now. For case 2, x is what? Between minus 1 and 1. Between minus 1 and 1. For that, this part here will be positive, but this part will be negative here. Okay, so you'll get here what? X plus 1 and minus x plus 1. X and x is cancelled. So what is left now? 1 plus 1, which is how much? 2. So this is minus 2x plus 2. This is what? Minus 2x. This is plus 2. And the last one will be, if you take x, the case 3, if you take like this, case 3, if you take x more than 1, both will be positive. So you'll end up with what? X plus 1 and x minus 1. X plus 1 and x minus 1. So 1 and 1 cancel. You'll have the answer as simply 2x. Getting my point? Both cases, case 1, 2 and 3. So you have this as the graph, and you get what? 2 critical points, but you check at both the points the function is continuous. There's no break in the function. There's no break in the function. For that reason, the function is continuous at both the points, and we get the result as as option A, continuous at both the points. Option A. It's a very good question. Little difficult, but for that reason only I've taken it over here and shown you with the help of graph, getting all the 3 cases. I'll highlight it for all of you. I will highlight it for all of you. Case 1 is right here with this as the result. Case 2 is over here with this as the result. Case 3 is here with this as the result. Is it clear? Answer is option A. One more time, check. Yes. Okay. Why this is important? No, because this can come in your other questions also. That's why it is important. Okay. It can come in the 3 marker as well. That's why it becomes very relevant for us. I'll show you in the questions that I've taken over here today. We have y. I'm looking for second derivative plus y. First find the first derivative. y1 you find first. You'll get minus 5 sin x. No. You'll get minus 5 sin x actually, because cos derivative is sine. So minus 5 sin x. This will be minus 3 cos x, okay, and if you take y2, derivative of the first derivative, so minus 5 cos x, and this will become what? Plus 3 sin x. Check here, take minus sign common, you get what? 5 cos x minus 3 sin x. Check here, this is y2, this is y2, minus, what is this? Same as y. Check here, 5 cos x minus 3 sin x. So minus y. Bring on this side, I get y2 plus y as 0. y2 plus y as 0. Answer is Option A. Answer is option A. Done. Next. Now we are moving to the 2-marker category. So we are done with the first 8 questions. Here we go. Question on implicit function. This is a question on a topic which is called as implicit function, where you can't make the subject as y or any other variable, okay? Because you have y plus sin y. How would you find it? You can't. You have to differentiate it like this itself and take dy by dx common. I'll show you. Differentiate this function. I have y plus sin y and cos x. Differentiate, you'll get here dy by dx, excuse me, here we get cos y dy by dx minus sin x. Take dy by dx common, we'll have the answer as 1 plus cos y minus sin x. What are we looking for? This value, hence we have dy by dx equals to minus sin x upon 1 plus cos y, and that's my answer. Fair enough. We don't have a y exactly as a subject, so we differentiate it like this itself. Take dy by dx common to get the final answer in this way. Okay, 2-marker question. Next, let's solve this one as well. Okay, we have a given condition. We have to prove that this is true. Differentiate it. It's again a model question paper. Sorry, not model question paper. Question bank, question number 23. Question bank, question number 23 for which question paper? So question bank of 2026 that they have released this year, okay, last week. Differentiate for root x, we just did right now. 1 upon 2 root x will come. For this we'll get what? 1 upon 2 root y. Is it over? Is it over? No sir, because for x derivative is 1, so we don't write that, but for y derivative is dy by dx, so we have to write that, and derivative of 10 is 0, so we'll move that part over here. So I get what? 1 by 2 root x as it is minus 1 by 2 root y dy by dx. Okay, check this out now. 2 and 2 is cancelled. Now what I can do, I can simply move on this side, okay, this whole thing. So I get here, this root y will come over here, root y upon root x equals to minus dy by dx. Simplify one more step and you'll end up with what? Root of y upon x. Move this over this side, so plus dy by dx is 0. Proved. This here is proved. 2 marks yours. Okay, 23 question from the question bank 2026. Easy, very easy. This is also PYQ actually. Next, find dy by dx if y equal to log of cos of ex is there. Okay, differentiate y1, we'll get what? For log 1 upon cos of e power x as it is. This is for log. Differentiate cos, we'll get minus sine e power x as it is. Now is it over? No sir, we have to differentiate e power x also. So e power x comes one more time, we get y1 as sine by cos, so minus tan e power x into e power x. Basically my answer is e power x with a minus sign, tan of e power x, tan of e power x. This is my y1. Check please. Simple problems. So in 1 marker, 2 marker, the questions are very much simple. Okay, again discuss the continuity of the function given here, sin x plus cos x, sin x into cos x. Tell me, for the domain that they have, what is the domain of sin x and cos x? Sin x and cos x domain is what? They are both all real. They are both all real. Okay, they are both all real. In their domain, sin x and cos x are always what? Continuous. So if you check here, this is your sin x function. Okay, and so on. And this is your cos x, sin x function like this, and cos x will be over here. Check. This is your cos x. This is your sin x, and here cos x. They're always continuous in their domain. Okay, so continuous everywhere in the domain. Continuous everywhere in their domain. Am I right? Am I correct? Yes. So if they are continuous everywhere in domain, then even what is it? Their sum will be continuous. Their product will also be continuous. F plus G, excuse me, F plus G and F into G will also be continuous in the entire domain. Getting my point? Yes. Next. 3 marker. Next is the 3 marker question. Let's see one by one. What do we have over here? Yes, the question on the continuity. We have to solve them to get the value of the variable. No, in this case we are looking for actually the relationship. We can't solve because we have 2 variables over here, so we can't solve 2 variables with the one equation. Okay, so we have to go with the relation only. Okay, so let's find for continuity. We have one rule, that limit of the function f of x when x tends to a, in this case 3, in this case in this case 3, in this case 3 should be equal to f of 3. Check the function. Wherever wherever we don't have inequality, use that function. Okay, for the limit part, so we get bx plus 3. So right here, bx plus 3, the limit x tends to 3, am I right? Yeah, should be equal to f of 3. F of 3 is what? Like, check here, equality present is in the first part, so ax plus 1. We'll write that later. Check here, so we get 3b plus 3 equals to, now in this function you're going to put what? In place of x you're going to put 3, so 3a plus 1, 3a plus 1. So I'm getting what? I can move b on this side, so I get 3 minus 1 equal to 3a minus 3b. So I get 2 equals to 3 of a minus b, which gives me a minus b value is nothing but 2 by 3. Moving 3 on this side, 2 by 3. So we are able to establish the relationship between the variables a and b when the given function is continuous at the point x equals to 3. Fair enough? Clear? Okay, sir. Aren't you having fun right now solving all the questions in this motivation one by one and scoring that 17 marks in this particular chapter for your PU2 boards? Okay. Another question where we have to find the continuity. We have to use the continuity to get what? To get the value of the variable a and b. Now in this case we can make 2 equations because we have 2 critical points. Check here, 2 and 10. So we'll have to do for 2 different places. Same thing. Let's do the limit function of fx when x tends to 2 should be equal to f of 2. Okay, for f of 2 we'll have 5. Check here, equal to sign is here, so f of 2 will be 5 over here and limit will be over here. So what we get for this part? Twice of a plus b. First equation. This is my first equation. Okay, f of x is this one. Put the 2 values, so 2 of a plus b. Next, what we get? Limit of the function when x tends to 10 should be equal to f of 10. Should be equal to f of 10. Okay, f of 10 you check is 21. So right here, 21. Now we put the value of 10 here, to 10a plus b. 10a plus b. This is my equation number 2. Equation 1 and equation 2. Do one thing, do 2a minus equation 2 minus 1. So 10a minus 2a is 8a, b minus b is 0, and 21 minus 5 is 16. So I get the value of a as 2. Value of a is 2. Value of a is 2 means 2 into 2 is 4. b will become equal to 1. Check please. So value of a is coming as 2, b is coming as 1. Subtract these two. 10a minus 2a is 8a, b and b is 0, 21 minus 5 is 16. Answer is what? 8a equals to 16, so a equals to 2, b equals to 1. Done. Both the variables are found out. Same question over here. Find the point of discontinuity for the given function. Answer: no point of discontinuity. Reason? Check here, mod x. The critical point is what? X equal to 0. Here we have x minus 1. X equals to minus 1. Check this out. Here we have the critical point as x equals to minus 1. If you draw them, you'll get a graph like this. Check here. I just draw it for all of you, right? Where's the graph? Where's the graph? This one, I think. Where is it? So we just learned it right now. Mod of x, mod of here, this one. You'll have a similar approach to that particular question. Mod of x plus 1, mod of x minus 1. That's why I taught you over here, so you can apply in that particular question. So do it right now and learn it from that part only. Check one more time. This is the concept and apply in this particular question over here. We have 2 critical points. We'll have 3 cases, okay, because number line will be like this. -1 and we'll have a 0. So we'll have one part over here. If you take both positive, what will happen to this? At 0 it will become simply after 0. It is minus sign actually. So it will become simply 1, I think. Okay, correct, no? If you take both positive, this will be also positive after 0, and this is also positive after 0. Okay, so we have both positive, x will go on. We'll have the answer as minus 1 actually. Please check x minus after 0 is positive, after 0 is positive. So yes, it's going to be minus 1 actually. So over here, minus 1 over here, y equal to minus 1. And between 0 and 1, this will be positive, this will be negative, this will be what? Positive, right? So we'll have minus x, and over here will be minus 1. If you put minus 0.5, will be positive only. So minus x minus 1. It becomes minus 2x minus 1, okay? This will be a line like this. Slope, negative slope will be there. Something like this. When x is 0, when y is 0, it's going to be what? The point is going to be minus 1 only, I think, right? If you put minus 1 over here, it will become 0, it will become simply 1, okay? So, okay. So, something like this will come. Okay, what is the point when it touches 0? Y equal to 0, it will touch at, it will come out as 0 where only when it is what? And this is for this part, after 0, before 0 and minus 1, check this out. So what will happen to this? It will become minus x, and this will be as it is. So again minus x plus 1 because, sorry, minus x minus 1 actually. Minus x minus 1 because you're going to open with the plus sign, right? Between minus 1 and 0, this will be with the minus sign, this will be the plus sign. Okay, because if you put any value between them, let's say minus 0.5 if you put, this will be what? Plus 0.5. So the mod will open with the plus sign. Not sure, let me show you for you. If I take minus 0.5 between minus 1 and 0 plus 1, what is the value? 0.5. What is the answer? 0.5. So basically between these two values, this mod will open with the plus sign. So it will become what? Minus x minus 1. Okay. So what is this? Y equal to minus x minus 1 means y equals to minus 2x minus 1. So this will touch the x-axis at you move on this side 0, will become 1 by 2, minus 1 by 2. Okay, so this will go like this, and at minus 1, like on the left side of the minus 1, this is when x belongs to minus 1 to 0. Okay, and this particular is when x belongs to more than 0, when x is more than 0, and this is case 1 over here. This here is your case 2, and check the case 3, when x is less than minus 1. What will happen then? Both will be negative, so it will become what? Minus x, and this will be minus of minus x plus 1. Check this out. This will become cancelled as plus 1. We'll have minus x plus 1 cancels. Answer will be 1. So this is your curve. So this is nothing but y equal to 1 curve. This is nothing but y equal to, sorry, 1. This is minus 1 curve. And this will be what? Y equal to minus 2x minus 1 curve. So if you check this graph, what I drew over here, from all the three cases, case 1 x more than 0, case 2 between minus 1 and 0, case 3 x less than minus 1, we are getting this curve. This curve is never discontinuous, hence the answer was this, right in point that no point of discontinuity. You don't have to draw all the points, but you can show it like this. There are three total cases, and you can continue like that. Because this question carries how many marks? Total of 3 marks. Please check. This carries 3 marks here. So it will take some, you have to show the 3 cases. This is case 1. This is your case 2. Okay. And this is your case 3. I hope this is clear. A very good question, challenging and difficult as well. But yes, part of your syllabus. Please check. Continue. Find the derivative of this one. Okay, take x as tan theta. What I get now? 1 minus tan square theta upon 1 plus tan square theta is nothing but cos 2 theta, right? Correct, no? This is the formula for cos 2 theta. So sir, it doesn't do any good to me. Actually it does. Let me show you. Sine inverse of cos 2 theta we are getting now so far. Okay, make this as sine inverse of sine of pi by 2 minus 2 theta. Now this is same. Check. Sine of pi by 2 minus 2 theta is nothing but cos 2 theta. Okay, now you differentiate this. So this will be cancelled. First you'll have y equals to pi by 2 minus 2 theta. Now put the value of theta back in. Theta is going to be tan inverse of x from here. Tan inverse of x. So y is nothing but pi by 2 minus 2 times of tan inverse of x, differentiate, y dash will be 0 minus 2 times of 1 upon this value, 1 upon x square. So answer is, what is it, minus sign only, no? Yeah, minus 2 upon 1 plus x square. That's my final answer. 3 marker. Very good question. Simple though. Okay. Differentiate the following with respect to x. Differentiate it. If I have here y dash will be what? E power x plus e power x square into 2x, the chain rule. E power x cube into 3x square plus e power x power 4 into 4x cube plus e power x power 5 into 5x power 4. Something is common? Is something common? No, sir. It is not common because we don't have x common, 2 common, 3 common, nothing is common. So this is your final answer. Nothing is common, sir. Okay, next. dy by dx of y equal to cos x, cos 2x, cos 3x. This is a logarithmic function, very, very important. So simply going to take this value as log of y, and over here log of cos of x, cos of 2x, and cos of 3x. Now differentiate, you'll have 1 by y. Sorry, before derivative, we have to apply the rules for logarithm, okay, on the right hand side. Let's check. So we have log of y as it is. It will be what? Log a into b into c will be log a plus log b, excuse me, cos 2x, no? Log b plus log c. Differentiated now. So I get 1 by y dy by dx equals to, we'll have over here derivative of cos. So 1 by cos we'll have here, and we'll have cos derivative as minus sin x, no? Minus sin x. Okay, directly I wrote. Yeah, minus sin x. Same over here we'll have again minus sin 2x upon cos 2x. Derivative of 2x will be what? 2. Correct, because we have cos log derivative will become 1 by cos. Cos is nothing but minus sine, and for 2x we'll have minus 2. Same approach over here, minus 3 sine 3x upon cos 3x. Check the final answer. You will have dy by dx as y. This y will go on this side, so y into minus tan x minus 2 tan 2x, excuse me, minus 2 tan 2x minus 3 tan 3x. That's your final answer. Put the value of y back in as cos x into cos 2x into cos 3x. Put the value of y as cos x, cos 2x and cos 3x. Fair enough? Clear? Next question. Okay. Derivative of this using the parametric form. How would you solve it? Solve for each of them individually and use the ratio. Okay, sir. Let's find from here. So dy by dx is given as dy by d theta upon dx by d theta. Okay, let's try this first. Dy by d theta first. Differentiate. A is a constant. Keep it as it is. 1 will be 0. This will become plus sine theta. Correct, no? Cos will become minus sine, so become minus and minus plus sine theta. Next we're going to move on to this one, dx by d theta. Okay, so that a is again a constant as it is. Derivative of theta will be what? 1. Sine will become cos. Okay, cos theta. So 1 plus cos is given by 1, 2 cos square theta by 2. Okay, 2 cos square theta by 2. Now continue. I'm looking for dy by dx, so there will be what? Dy by d theta upon dx by d theta. What is it? A sine theta divided by a into 2 cos square theta, no? A into 2 cos square theta by 2 actually. Cos square theta by 2. One more step, check here. Value of sine theta is what? 2 sine theta by 2 into cos theta by 2. Correct, no? Sin theta formula is there. 2 sin x. If it is sin 2x, formula is 2 sin x into cos x. Same we have here. A2 cos square theta by 2. So a cancels, 2 cancels. This one of the cos is cancelled. Answer is sin by cos. So tan theta by 2. That's my derivative dy by dx in terms of the parameter theta. In terms of parameter theta. Okay, done. Next, find f dash if the f is given a sine inverse of 2 power x plus 1. Okay, like this. First step, write this, write this f of x, sine inverse is there. Write it as 2 times of 2 power 2x, and we have 1 plus 2 power x times of 2. I've done nothing but using the exponents rule. Power rule I've used. X plus 1 is there, so there is a sum rule, okay, product rule. So 2 times of 2 power x, and this is 2 power x power 2, the power rule. Power gets multiplied. Okay. What next we have? Sine inverse as it is. I'll write 2 power x. As tan theta. So it will become what? X will become, what is it? Sorry, not x. I'm writing this over here as well. Theta will become tan inverse of 2 power x. Just for reference, we're going to use it later, no? That's fine. So we have 2 tan theta upon 1 plus tan square theta. This, if you know it, if the formula is there for this as sine 2 theta, this whole thing becomes what? 2 theta. This is your f of x. Yes. Now what are we looking for? The derivative actually. So try from here. F dash of x will be what? Derivative of, okay, one more step first before I start derivative. 2 times of, write the theta value, tan inverse of 2 power x. Differentiate now. F dash of x. So 2 as it is, 1 upon 1 plus 2 power x the whole square. Derivative of 2 power x now with the chain rule. So we'll get 2 power x only and ln 2. So it will become what? 2 power x into 2. So 2 power x plus 1 ln 2 divided by 1 plus 4 power x. 2 power x the square is nothing but 1 plus 4 pi x. This is my value of derivative, sir. This right here is the value of derivative. Please check. Okay, done. Have a look. All right, next we are moving to the 5 marker category. Now let's solve these questions, and we can say our chapter is over for 17 marks preparation from one of the most important and easiest chapter of calculus, continuity and differentiability. Next, what we have, check, determine the value of k. This is a 4 marker also, sometimes it comes for 4 marker as well. K cos x upon pi minus 2x when pi is not and x is not is pi by 2, and when x is pi by 2 it is 3. Okay, sir. Limit value. They've given it is continuous at this particular value, x goes to pi by 2. So limit value of the function when x tends to pi by 2 should be equal to f of pi by 2. Okay. Apply now. So we'll get what? We'll have k cos x upon pi minus 2x when limit x tends to pi by 2 equals to f of pi by 2 means this value is given as 3 over here. I've told you guys, you have to apply LH rule over here. This is faster and easier as well. If you apply LH rule, take here, apply LH rule, get the answer. So differentiate under the limit. Okay, sir. So limit x tends to pi by 2 only, right? X tends to pi by 2. Differentiate k into cos will be minus sine x divided by pi is 0, so minus 2. X derivative is 1, so minus 2 equals to what? Equals to 3. Okay, this minus minus cancels. I have k sine of pi by 2 upon 2 equals to 3. Sine pi by 2 is 1, so k into 1 equals to, bring this 2 on the side, 6. So value of k is what? 6. Value of k is what? 6. Fair enough. 4 marker question. Okay, now differentiate this. This is a question from logarithmic differentiation, comes for a very high weightage. So what is given to you? Y equals to, this is given, right? Apply log. When you apply log, what does this mean? The root means the power as 1 by 2. Root means power as 1 by 2, and in log power comes in front as the coefficient. So 1 by 2. And we'll have here log. Now when you have log of the product, it will become what? As a sum. So log of this plus log of this. And the ratio will become what? Difference. So minus log of 3x square plus 4x plus 5. This is your log. So the product will become sum, the ratio will become the difference. Now you're going to take the derivative. So you'll have 1 by y dy by dx, 1 by 2 as it is. Differentiate log, you'll have x minus 3 and simply 1. Over here you'll have 1 upon x square by 4, and derivative will be what? Of this x square plus 4 will be 2x. Over here minus sign is there. So 3x square plus 4x plus 5, and over here we'll have what? 6x plus 4. This is my derivative. Okay. LCM. That's your answer actually. If you want to take LCM, if you can do that, go ahead and do it. Okay. Let's just simply calculations of these steps. The answer will be y upon 2 times of this whole thing. That's the result. Do the calculation please. Y on this side, okay, 1 by x minus 3 will not be completely factorizable, so you have to continue like this only. Do the multiplication and get the result from here. It will become x square plus 4 into this, and over here you'll have 2x into like this. So yeah, okay, that's your answer. Next one, sir. Another question on the parametric form. We are very close to completing our syllabus from the chapter continuity and differentiability. So please don't give up right now. Let's complete all these questions. I have how many? Let's check. I have how many? We are right now over here. So we have only 3 more to go. Only 3 more to go. Let's complete them and our session will be complete and prepared also from this particular chapter. X and y are connected parametrically by the equation given in this format. Find dy by dx. Okay. So we'll do first dy by dx we are looking to find. So we have to go like this, dy by dt upon dx by dt. Let's find dy by dt first. For this one, we'll have dy by dt as a cos t. A cos t, right? A sin t will become a cos t. Now we have to move to dx by dt. Okay. And for this we'll have a as it is, common. Derivative of cos will be what? Minus sin t. And for log we'll have what? 1 upon tan will be as it is. So tan t by 2. Tan will be what? Derivative as sec square t by 2. And we'll have derivative of t by 2 as 1 by 2. So I can write this 2 over here as simply in front of tan. Derivative of t by 2 will be 1 by 2, so 2 I can write in the denominator or simply with the tan. Okay, continue over here. So we have what? We have a, check this out, minus sin t as it is. Everything is on this step. So we have 1 by 2. Tan t by 2 is how much? Sin t by 2 and divided by cos t by 2. Tan t by 2 is sin by cos. Sec square will come in the denominator. We'll have 1 upon cos square t by 2. Right? So check this out. This cos t by 2 and this will cancel. Okay? We have 2 sin t by 2 and cos t by 2. Last step for this particular derivative. A as it is. We have minus sin t as it is. And this becomes what? 1 by, check this out, 2 sin t by 2 cos t by 2. The formula is sin into 2 times of t by 2. So sin t. Not sure? Have a look. No problem. 2 sin t by 2 cos t by 2. Formula of sin 2a. 2 sin a cos a. Same approach. 2 sin a cos a. It becomes sin 2a. So answer is what? Sin t. Multiply now. You get a. It will become minus sin square t plus 1 upon sin t. So we have dx by dt as, check this out, it will become a cos square t upon sin t. I'm looking for this value over here, so use that last. Dy by dx will be equal to this particular value over there. What is that? A cos t. Check. A cos t divided by a cos square t upon sin t. upon sin t. So a cancels, cos and one of the cos cancel. This will go in front, up actually. So I have here sin t in the numerator divided by cos t. The answer is coming as what? The answer is coming as actually tan t. This is my final answer. Final answer is tan t. Derivative is coming as tan t. Check. dy by dx is coming as tan t. Superb question. Okay. One more time, have a look. First, dx by dt we got. First we got dy by dt. We solve for dx by dt, use the formula of sin 2x, and over here we have the result as a cos square t by sin t. Use the ratio, getting the answer as tan t. Next, find the second order derivative of the functions and show that this is true. Okay, sir. Differentiate from here. E power y x plus 1 equal to 1. We have differentiate e power y x plus e power y equals to 1, right? Differentiating this will give me what? E power y as it is. Okay, why to do that actually? Not required. We can do directly, no? No need to expand it. No need to expand it. So e power y as it is, differentiate x plus 1, I get 1. This time keep x plus 1 as it is, differentiate e power y. So e power y dy by dx equals to 0. Now take e power y common. Okay, you'll have 1 and you'll have what is it? Yeah, 1 plus dy by dx okay, into x plus 1 equal to 0. Into x plus 1 equal to 0. So if you know, this is nothing but a non-zero value. This is a non-zero value. Non-zero value. This is not ever 0. This is non-zero. Okay, it means from here we get that this part has to be equal to 0, because the product of this and this is 0, product of e power y and this particular bracket is 0, and this is a non-zero value, means this particular bracket has to be 0 over here. So I get this as 1 plus dy by dx equals to x plus 1 as 0. Check. So I'm getting this as dy by dx equals to into x plus 1 equals to minus 1. So I get dy by dx equals to what? Minus 1 upon x plus 1, the first one. Differentiate this one, I'll get d square y upon dx square will be equal to, take this derivative of this will be what? Minus of minus 1 upon x plus 1 the whole square. I'm getting this value as 1 upon x plus 1 the whole square. So now if you check carefully, so what we are getting the answer as, this is my value of second derivative and this is the value of first derivative. If you compare, my second derivative is actually coming as the square of the first derivative, sir. The square of the first derivative. Square derivative of the first derivative is minus 1 upon x plus 1 the whole square. That will come as 1 upon x plus 1 the whole square. So you have proved it over here. Second derivative is nothing but square of my first derivative. Is it clear? Second derivative is nothing but square of my first derivative. Okay, let's move on. So this is your last question. This is a PYQ as well. I have to find and so that this is true. This is true for the given function. Differentiate y1 will be what? 2 times of tan inverse of x, okay, divided by 1 plus x square. Am I correct? 2 times of tan inverse of x divided by 1 plus x square is the derivative of y for the first time. Multiply on this side. I get y1 into 1 plus x square equal to 2 tan inverse of x. Okay, now you can differentiate it one more time. y1 will become y2 and this will be as it is. Now this time keep y1 as it is. Okay, excuse me. Yeah, y1 will become y2 and this time you're going to keep y1 as it is and you'll have this value as 2x. This value as 2x. Okay, now differentiate this side. You'll have 2 upon 1 plus x square. Cross multiply, you'll end up with y2 times of 1 plus x square. This and this will multiply, becomes whole square, and over here you'll have 2x times of 1 plus x square into y1 equals to 2. Check. Is it what they're asking? y2 into 1 plus x square plus 1 the whole square, 2x times of this into y1 equals to 2. We have proved this one. That's it. This is a PYQ also. Okay, very oftenly you can see this question in your papers. So this completes your session on the C&D. The important topics would be, again, definition based question will come. The definition rules are, which is there: quotient rule, product rule, chain rule. The formulas, which is very, very important. Second order derivative, parametric form are the important topics of this particular chapter, alongside with logarithmic differentiation. When the function is given in the form of f bar g, or f into g, or f by g. These three forms are there: f into g, f bar g, and f by g. Three forms are there. You're going to apply log on both sides to get the result. Remember this kind of a function? Yeah. So this is also very, very important. Comes for 3 marks sometimes. Okay. So you have to understand this very clearly. The important topics I've discussed, all of them. I've solved all these questions, including PYQs, including your MCQs. So do benefit from it. Okay. And this is the session which helped you score 17 marks. Okay, but yes, you might have some doubts, so you can let me know in the comment section right now. Okay, I'll reply to all of your comments, but I hope I've cleared all the concepts. Do let me know if I have missed out on something. This is it for the session today. Thanks for listening to me in this particular class. Till then, I'll see you again in the next class. Till then, take care. Bye bye.